Every single day, we are just swimming in this massive sea of data, right? Numbers, charts, figures, it's everywhere. So the big question is, how do we actually make sense of it all? Well, in this explainer, we're going to dive into the basics of statistical thinking. It's an absolutely powerful way to find some real clarity in all that chaos.
Okay, let's kick things off with a little puzzle. Imagine you're looking at some data. In one column, you've got daily temperatures, and in the other, you've got the number of customers who walked into a store. Now, if you just look at it, it's a total jumble of numbers. It's messy, it's chaotic, and that's what we call noise. Honestly, it's pretty tough to see any kind of story in there, isn't it?
And that brings us right to the heart of the matter. How do you turn all of that noise into a clear, understandable signal? How do we find the real story that's hiding inside all that data?
Well, the good news is there's a really powerful method for doing exactly that. It's an entire field of science, actually, designed specifically to find that clarity in the chaos.
And that method? It's called statistics. Basically, it's the science of collecting, organizing, summarizing, and then analyzing data. The whole point, really, is to answer questions and draw some meaningful conclusions from what can often look like just a bunch of random information.
So this entire field of statistics is really built on just two simple but super powerful ideas. First up is variation. That's just the simple fact that things, well, they change. My height isn't the same as your height. Today's weather is different from yesterday's. And the second idea is data. These are simply the observations we gather to actually measure all that variation.
All right, so once we've got our data, what's the first move? Where do we even start? Well, the first step is to find its center of gravity. Its typical value. We've got to ask ourselves, where is the middle of all this data?
The most common way to figure that out is with the mean. You've probably heard of this. It's just the good old numerical average. You just add everything up and then you divide by how many numbers you have. It's the exact same thing you do to get your average test score. Super simple and really effective.
Next up, we've got the median. Now to find this one, it's pretty straightforward. You just line up all your data points in order, from smallest to largest, and you find the one that's smack dab in the middle. It's the 50th percentile, which just means half the data is below that number and half is above it.
And finally, there's the mode. And this one? It's the easiest of them all, for sure. It is literally just the value that pops up the most often in your data. It's the most common result, plain and simple.
So here's the really crucial part, knowing which one of these 3 M's to actually use. See, if your data is pretty symmetrical, think average salaries in a company where nobody's making $1 bajillion, the mean works great. But what if you have some extreme values, like a few multi-million-dollar mansions in an otherwise normal neighborhood? Those huge numbers can pull the mean way, way up. In a case like that, the median is your friend. It's going to give you a much more realistic picture of what a typical house actually costs.
Okay, so finding the center is a fantastic start, but it's really only half the story. To truly understand our data, we also have to know how spread out it is. Are all the numbers clustered tightly together, or are they kind of all over the place?
And our main tool for figuring that out is called standard deviation. Now, I know, the name sounds a little intimidating, but don't let it scare you. It's actually just a number that tells you, on average, how far each data point is from the mean. So, if you have a small standard deviation, it means your data is all bunched up and consistent. If you have a large one, well, that means it's spread all over the map.
And this leads us to one of the most useful rules of thumb in all of statistics. It's called the Empirical Rule, and it's awesome. For lots of common types of data, you could expect about 68% of all your values to fall within one standard deviation of the average. If you widen that out to 2 standard deviations, you've captured a whopping 95%. And at 3 standard deviations, you've got pretty much everything, 99.7% of it. It is a fantastic shortcut for just getting a feel for your data.
All right, now we get to the really exciting stuff. So far, we've learned how to describe one set of numbers. But what happens when we want to see if 2 different things are connected? Can we actually find patterns between them?
Let's circle back to our original data. Remember that messy table with temperatures and customers? Well, look what happens when we organize it and, visualize it. Suddenly, the signal starts to emerge from all that noise. It sure looks like when the temperature is high, the number of customers is low. And when the temp is low, customer numbers are high. We've found a pattern.
And get this, we can even put a number on how strong that pattern is. It's called the Pearson correlation coefficient, or just R for short, and it goes from -1 to +1. A value this close to -1,
Wow, that tells us we have a very strong negative relationship. As one thing goes up, the other one pretty reliably goes down. We found our signal.
But hold on. Before we start celebrating and declare victory, there is one final, crucial lesson we have to learn. And honestly, it might just be the single most important rule in all of statistics. Here it is. Ready? Correlation does not equal causation. Let that sink in for a second. Just because two things are related, even if they're super strongly related, it does not automatically mean that one is causing the other. Just think about our example, right? Does the hot weather actually cause people to stay away? Maybe, but maybe, just maybe, there's another factor at play. What if it's a holiday week that just happens to be hot and pretty much everyone has left town? See, the correlation points us in the right direction for sure, but it is not the final proof.
So, there you have it. We've gone on a journey from pure noise to a clear signal. We've seen how statistics can help us organize our world and uncover these amazing hidden patterns. And that leaves us with one final big question to chew on. You've just seen how statistics can reveal the truth, but how can they be used to hide it?